In this lesson, we'll be looking at the mole concept. And what is a mole? Now, we know that chemical reactions take place between individual particles. And from our previous class, we learned that the particles of a substance could be atoms, molecules, or ions. So when chemical reaction takes place, the reaction is actually between these particles. But these particles are so small, they are extremely small and difficult to work with individual particles. In other words, we cannot carry out chemical reaction by counting individual particles and then reacting them together. There is usually a common practice to weigh out the reacting substances that are needed before a chemical reaction can take place. So, because there's a need for weighing out a certain amount of these substances, then there's a need for a unit for measuring the amount of particles in a given mass of a substance. This unit should contain a specified number of particles, and such quantitative unit is what we call the mole. The mole, therefore, is the amount of substance containing as many elementary entities as the number of atoms in exactly 12 grams of carbon 12. Now, to understand the concept of mole better, I love to use the analogy of a dozen. Now, when we say dozen of something, irrespective of whatever that thing is, as long as it is a dozen, we know that it's 12 of that thing. For example, if you say a dozen of egg, how many egg? It is 12 egg. If you say a dozen of oranges, how many oranges? It is 12 oranges. The same thing applies to mole. As long as it is one mole of something, then that one mole of that thing contains as many elementary entities as the number of atoms in exactly 12 grams of carbon 12. Now, what do we mean by elementary entities? The elementary entities are the atoms, the molecules, or the ions, depending on the type of substance in question. Now, if the substance is an element, then the elementary entity, of course, should be atoms. If it's a molecule, now remember that molecule could be molecule of element or molecule of compound. Then in that case, the elementary entities will be molecule. Then if the substance is charged particles, then the elementary entities are ions. So through experimental work, it was found that one mole of 12 grams of carbon 12 contains 6.02 times 10 to the power of 23 atoms. That is, whenever you weigh out 12 grams of carbon 12, this is the number of atoms you are going to obtain from 12 grams of carbon 12. And this number is given a special name called the Avogadro number or the Avogadro constant. That is one mole of carbon 12, which is also the same thing as 12 grams of carbon 12. So carbon is monoatomic. So one mole of carbon 12 is equivalent to 12 grams of carbon 12. Contains 6.02 times 10 to the power of 23 atoms. So remember in our previous lesson where we talk about relative atomic mass, we say carbon 12 is used as a standard. So it is here, used as a standard again in our definition of mole. So one mole of any substance at all is what? The amount containing as many elementary entities as the number of atoms in exactly 12 grams or one mole of carbon 12. So that when we say one mole of an element like sodium, which is monoatomic, then we say how many atoms does it contain? As long as it's one mole of sodium, it should contain 6.02 times 10 to the power of 23 atoms. That is why I decided to use the concept of a dozen to explain this. Now, dozen of anything at all, we know that as long as it's a dozen, one dozen, it contains 12 of that thing. The same thing applies in one mole of anything, whether it's an element, molecule, or a compound, as long as it is one mole of that, it contains 6.02 times 10 to the power of 23 elementary entity. Here I say atom because of course sodium is an element. So the elementary entity of element is atom. Now one mole of a compound like sodium hydroxide. Now here, the elementary entity should be molecule because sodium hydroxide is a compound. Now, it contains 6.02 times 10 to the power of 23 molecules, in this case, not atoms. So the elementary entity of a compound are molecules. And so that is that for mole. As long as it's one mole of anything, the number of elementary entity should be 6.02 to the power of 23. And this number is the Avogadro number or the Avogadro constant. Now, the definition of one mole of a substance gives the following relationship: the number of moles of a substance. The number of moles is defined as the number of particles divided by 6.02 times 10 to the power of 23. The number of moles is equal to number of particles, and matter is lagging, number of particles divided by 6.02 times 10 to the power of 23. Okay? Another definition for number of moles will be reacting mass over molar mass. Now, why is it reacting mass over molar mass? We know that one mole of any substance has 6.02 to the power of 23 elementary entity. And that one mole, the mass of one mole of any substance is known as the molar mass of that substance. Therefore, we can replace it 6.02 times 10 to the power of 23 with molar mass. So that number of moles is equal to reacting mass over molar mass. This is an extension of the first formula because the molar mass, one mole of any substance, the mass of it is called the molar mass. And we know that one mole of any substance, so reacting mass over the molar mass. And molar mass, as I said, is the mass of one mole of a substance expressed in grams. So if I have H2, for example, which is a molecule of hydrogen, and this is one mole of hydrogen molecule, then the mass of this expressed in gram can be seen as the molar mass of this. That is why I say molar mass of a substance. The substance could be a molecule of an element. It could be a molecule of a compound. So mass of this expressed in gram, which is 2 grams for that of hydrogen, will be the molar mass of hydrogen. Then when it becomes a molecule of a compound like NaOH, the mass of this, because this is 1 mole of sodium hydroxide, the mass expressed in gram is the molar mass of this. And to get this, of course, we add the masses of all the constituent elements. In this case, sodium. Sodium is 23, oxygen is 16, and hydrogen is 1. That's 23 plus 16, that is 39, then plus 1, 40. So the molar mass of sodium hydroxide is 40 grams. Then, in summary, the mass of 1 mole of a substance expressed in gram is known as the molar mass of that substance. And as long as it's 1 mole of that substance, it contains 6.02 to the power of 23 elementary entities. The elementary entities could be atoms, it could be molecules, it could be ions, depending on the type of substance. We have an example here. The first one says, what is the mass of 3 moles of oxygen gas? Given that 1 atom of oxygen is 16, the mass of 3 moles of oxygen gas, and we know that number of moles is equal to reacting mass over molar mass. The number of moles is equal to mass over molar mass. So that since the question asks us what is the mass, that means if we cross multiply, then mass will be number of moles multiplied by the molar mass. Oh, my network is. So as I was saying before the network disconnected, if number of moles is equal to mass over molar mass, now the question is asking us to calculate the mass of 3 moles. So if I make this the subject of this equation, that means mass will be number of moles times molar mass times molar mass. So the question here is, it says 3 moles of oxygen. By the way, what is molar mass of oxygen? We say molar mass of a substance is the mass of 1 mole of it expressed in gram. 1 mole of oxygen is written as O2, meaning oxygen is a molecule. It exists as a molecule, diatomic molecule. So this value 16 here is 1 gram of oxygen. So 1 mole of oxygen is 16 times 2 because it exists as a molecule. The 16 times 2, which is 32. Therefore, the molar mass of oxygen is 32 grams. Therefore, mass of 3 moles of oxygen will be number of moles, which is 3 now, multiplied by the molar mass, which is 32. The mass equal to 3 times 32. And 3 times 32 is 96. So 96 grams is the mass of 3 moles of oxygen. Okay, the next example say how many atoms are there in 6 grams of carbon, given that 1 mole of carbon is 6 times 10 to the power of 23, and carbon has a relative atomic mass of 12. To answer that, we know that 1 mole of any substance is 10 to the power of 23, and any substance has a mass known as the molar mass of carbon is 12 grams of carbon, because carbon is monoatomic. 1 atom of carbon there, which is 12, as shown there. Okay, so as I was saying before, the disconnection. Now, for carbon, 1 mole of carbon is equivalent to 12 grams of carbon. Because carbon is monoatomic, it's 12 grams of carbon. So if that is the case, we know that number of moles is equal to mass, the reacting mass over molar mass. Now, the question says, how many atoms are there in 6 grams of carbon? Now, I want to get how many moles we have in 6 grams of carbon. Since the number of moles is mass over molar mass, 6, that is 6 divided by molar mass of carbon, which is 12. So number of moles in 6 grams of carbon will be 6, that is the mass, divided by the molar mass of carbon, which is 12. And 6 divided by 12 is 0.5, that is 0.5 mole. So if 1 mole of carbon contains, according to what we have in the bracket, the omitted is 0.02. The actual value is 6.02 times 10 to the power of 23. And when you have a question and it's follow the instruction to the letter, so we're going to use the one given to us here. So that we say 1 mole of carbon contains 6 times 10 to the power of 23. Therefore, 0.5, which is the number of mole in 6 grams, 0.5 mole will be what? 0.5 mole, of course, that will be half. Will contain X. So that by simple proportion, X equal to 0.5 times 6, and times 10 to the power of 23. And 0.5 times 6 is 3. So 3 times 10 to the power of 23 atoms. I hope this is clear enough. So the question is, how many atoms are in 6 grams of carbon? Now, to get the number of atoms, 1 mole of any substance, in this case, carbon is an element, so 1 mole of element contains 6.02 times 10 to the power 23 atoms. However, in this instruction, they omitted the 02 and gave us only 6 times 10 to the power 23. So 1 mole of carbon contains this. Then what will 6 grams of carbon contain? 6 grams of carbon is half mole of carbon, because number of moles is mass over molar mass. Molar mass of carbon is 12. So 6 divided by 12, which is 0.5 mole. So if 1 mole is 6 times 10 to the power 23 atoms, 0.5 should contain 0.5 times 6 times 10 to the power 23, which is 3 times 10 to the power 23 atoms. The next question 6 is, how many moles are there in 20 grams of calcium carbonate? Let me make room in this, on this board first. Okay, number of moles is mass over molar mass, and molar mass of calcium carbonate will be mass of the individual atoms added together. Okay, they give us a value here already, which is 100. So it's 100 gram. Molar mass is mass expressed in gram. Mass of 1 mole of that compound expressed in gram. This is different from relative molecular mass. When you say relative, then there is no unit. But molar mass is unit. So if number of moles is mass over molar mass, and molar mass of calcium carbonate is 100 grams, then number of moles in 20 grams will be 20, which is the mass, divided by the molar mass 100, and 0.2 mole. Then the second example says, how many moles are there in 30 grams of calcium chloride? Given that calcium chloride is 111, and the molar mass is 111. Okay, number of moles, mass over molar mass, they have given us the molar mass of calcium chloride. We'll just substitute the value right away. I said the mass is 30 grams, so the number of moles therefore is equal to 30, which is the mass given to us, divided by the molar mass, which is 111. And 30 divided by 111 at 0.27. 0.27 mole is the number of moles in 30 grams of calcium chloride. Then the third example says a sample of aluminum has a mass of 6.3 grams. Calculate 1, the number of moles of aluminum, 2, the number of atoms of aluminum in the sample. Okay, again, number of moles is mass over molar mass over molar mass. For monoatomic elements like aluminum, their molar mass is the same thing as their atomic mass, since 1 mole of a monoatomic element contains just one atom. So the point here is molar mass of aluminum is the same thing as this atomic mass given to us. So now, if number of moles is mass over molar mass, the mass given is 6 point. So number of moles then is equal to 6.3 divided by the molar mass is 27. 6.3 divided 27, 0.233 mole. That's question I. Then question I say the number of atoms of aluminum in the sample. Now, in that sample, this is the mole of aluminum. And we know that 1 mole of aluminum contains how many atoms? Well, the question says we should calculate the number of atoms in this very sample. 1 mole of aluminum contains 6.02 times 10 to the power 23 atoms. That's the Avogadro constant. Just like 1 dozen of egg is 12 egg, or 1 dozen of orange is 12 oranges. 1 dozen of anything is 12 of that thing. So 1 mole of anything is also 6.02 times 10 to the power 23 elementary entity. In this case, the elementary entity for an element like aluminum is atom. So atoms. So if 1 mole contains this number of atoms, what would this 0.233 contain? 0.233 mole of aluminum will contain X. So by simple proportion, we cross multiply this. X is equal to 0.233 times 6.02 times 10 to the power 23. So when we multiply this, multiply by 6.02, that is 1.40, 1.40 approximately, times 10 to the power 23 atoms. That is the number of atoms in that sample of aluminum. And then the last question on this template is, how many grams and moles of gold are present in 500 grams of gold oxide, given that the atomic mass of gold is 197 and that of oxygen is 16? Okay. The question is, how many grams? When they say how many grams, they are asking for the mass of something. So how many grams and moles of gold are present in 500 grams of gold oxide? And the formula for gold oxide is A2O3. So that we need to get the mass of gold. But before we do that, we need to get the molar mass of gold oxide. So that molar mass of gold oxide is equal to the atomic mass of gold, which is 197. But in gold oxide, there are 2 atoms of gold. So multiply it by 2. Because this 197 is for 1 atom. So the 2 atom will be 197 times 2. Then plus the same thing in oxygen, the atom is 16, but in gold oxide, there are 3 atoms of oxygen. So 16 times 3. So that 197 times 2, which is 394, plus 16 times 3 is 48. So adding 394 to 48, we have 442. So molar mass of gold oxide is 442 grams. But the question is asking us, there is this particular sample of gold oxide given to us. The mass is 500 grams. It is in this sample they want us to know the amount of gold in grams. So to do that, for any sample of gold oxide, there are what? 197 times 2 grams of gold in it. That is 1 mole of gold oxide contains 197 times 2, which is 394 grams of gold. Now this 1 mole is of course 442 grams. That is 442 grams of this gold oxide is the one that contains this 394 grams of gold. Then what would this 500 grams contain? 500 grams of gold oxide will contain X. Now cross multiply this 442 X This will multiply x, while 500 will multiply 394 is equal to 500 times 394. So that to find x, we divide both sides by 442. Therefore, x is equal to 500 times 394 divided by 442. That is 445.7. 445.7 gram, meaning 500 gram of this sample of gold oxide contains 445.7 gram of gold. That is the first part of the question, because the question says how many grams. When they say how many grams, they are asking you to calculate the mass of that thing. Then how many grams are moles? Now we need to get the number of moles in this, what is it? 500 and 445.7 gram. The number of moles is mass over molar mass, but to mass over molar mass. The mass is this 445.7 in 500 grams of gold. Of gold oxide contain this gram of gold. Then the molar mass of gold is 197. Why are we not using this 394? The 394 is not the molar mass of gold. 394 is the mass of gold in gold oxide. The molar mass of gold is this 197. Gold is monoatomic. So atomic mass is the same thing as the molar mass. As 1 mole of gold has 1 atom of gold. So the molar mass is 197. So 445.7 divided by 197, 2.26. 2.26 mole. Okay.